Welcome to the Ecotechie. In today's video, we are going to learn about support vector machines. Now, support vector machine is also a supervised learning algorithm which is used for regression and classification. In this video, we are going to look at the explanation of support vector machine diagrammatically. In the future videos, I will be explaining it mathematically and doing the code for the same. Now, let us jumpstart and understand what exactly is this support vector machines. Support vector machines are a set of supervised learning. So basically, supervised learning means that we have our independent variable and we have our dependent variable. And all our variables are properly labeled for us, which is used for classification. So we have already learned about classification, wherein we are dividing the groups into people who have passed the examination, people who have failed the examination, people who have corona and people who do not have corona. And we have learned about regression. Regression is basically establishing a linear relationship between independent variable and dependent variable. Over here, support vector machine has a USP. What is its USP? It's that outlier detection. So when we were learning linear regression and logistic regression, we had to deal with outliers, because if we do not deal with the outliers, our answers or our solutions would not be perfect. We had to sit and individually deal with different outliers, but support vector machine does that work for us. Support vector machine is preferred over all other machine learning model mainly because of its accuracy and the less computation power. In the end of this video, you will understand how exactly is it using less computation power to come up with greater accuracy. Now, let us look at the objective of support vector machines. So, the objective of support vector machine is to find a hyperplane in an n-dimensional space that distinctly classifies the data point. Over here, one more thing to remember. So, if we have a plane, then our hyperplane would be a line. So, if the dimension is r raised to n, so you have the hyperplane as r raised to n minus 1. So one dimension less than the dimension of our feature space. So now you would be wondering, what exactly is this hyperplane? It's very confusing. In future, I'm going to break down the meaning of hyperplane, what exactly a hyperplane does, and so on and so forth. Now, it is very normal to divide the dataset into two using a line. You can draw a line anywhere you like. But drawing a line anywhere you like, is it a good solution for us? Maybe not. Sometimes there can be misclassification. Like if you look at this line, here are certain points which are people who have failed the examination. So the stars are people who have failed the examination and the boxes are people who have cleared the examination. There is a misclassification of this star over here. So definitely this is not a right thing. Then what exactly should we do? We have to look at the hyperplane. Now what exactly is a hyperplane? A hyperplane is a line which divides the data points. Okay, all these lines are doing it, then what is the problem? There is a catch over here. A hyperplane is a line which divides the two data points or data points in such a way that the error margin is as large as possible. Now what exactly is this error margin, you would be wondering. Slowly, I will give an idea of what exactly it is. I hope the idea of hyperplane is clear. Now, let us deep dive further. So, this is how a hyperplane looks like. A hyperplane is a line or a plane. See, if you have a larger dimension, you will have a plane. If you have a smaller dimension like a plane, you have a line. A line which divides the data points into two groups. Now, over here, you have something known as decision boundary. Hyperplane is also a decision boundary. There is something known as boundary lines. Now, what are boundary lines? Boundary lines are the lines which are closest to the data points. Now, over here, you have certain points very close to the hyperplane. So basically the points which are very close to the hyperplane, this point, they are called as support vectors. You would be wondering why exactly do you call it support vectors? So basically to understand that, your decision boundary lies on the support vector. So these points support your decision boundary, hence they are called as support vectors. And your support vectors decide the orientation of your hyperplane. How exactly the hyperplane should be, what is the slope of the hyperplane, this is determined by your support vectors. Hence they are called as support vectors. Now the difference between the boundary line and the hyperplane is the margin or the error margin. So what is a hyperplane? A hyperplane is a line which divides the data into two parts in such a way that the error margin is as large as possible. Because higher the error margin, you are more sure about the things. If the error margins are low, you are less sure about dividing the data into pass and fail. Now, let us revisit these terms. So, a hyperplane is a decision boundary which separates the two classes. Support vectors are the data points which are closest to the hyperplane. Boundary line are the lines apart from hyperplane which creates a margin. It separates the two classes. Support vectors can be on the boundary line. An error margin, the difference between the hyperplane and the boundary line is nothing but the error margin. So these are the terminologies which are a part of SVM. Now we have just briefly looked at SVM and diagrammatically understood what exactly SVM does. Now we have to look at the advantages and disadvantages of SVM. Because whenever we learn a model, it is important that we understand what are the advantages of this model and disadvantages of this model. So the first advantage is that it is highly effective in a high dimensional space. What does it mean? If your number of features or your x1, x2, xn is large, it is highly effective. The second feature or the advantage is that it is effective where the number of dimensions are greater than number of samples. So if you look at linear regression, you will not be able to build a model if your number of dimensions are way greater than number of samples. But over here, SVM easily handles it. Finally, it's memory efficient as it uses a subset of training data points support vector in the decision function. So basically, it's memory efficient. Why? In linear regression, we used to use the entire training data to come up with a solution or the prediction. But in case of SVM, we are only going to look at the support vectors. We had seen that support vectors are the points which are very close to the hyperplane. So when you are using less amount of data, you will use less amount of memory space. Hence, it is highly memory efficient. Now, there are disadvantages as well. So the first disadvantage is that it is not suitable for large data sets. Normally, most of our machine learning models perform better when we have large data set. Unfortunately, SVM does not perform better when we have very large data set. It does not perform well when there is a lot of noise in the data. Finally, there is no probabilistic explanation for classification. You'd be wondering what exactly this disadvantage is. So basically, uh, if you see logistic regression, in logistic regression, we used a sigmoid function and crunched all our numbers into probabilistic model values. So your values ranged between 0 and 1. And we set a threshold of 0.5 or anything that you like and decided if the value is above 0.5, then the person has corona. If the value is less than 0.5, the person does not have corona. We decided something like that and we got probability values. But over here, we do not have any such sigmoid function which is changing. It's a line over here, so it remains a line. There is no sigmoid to change it into probability. So what happens over here, there's something known as reinforcement range. So sigmoid function made our range between 0 and 1, while reinforcement range will make our range between -1 to 1. So if your values are less than -1, it will be considered as not having corona, and if your values are greater than 1, it would be considered as having corona. So there is no probabilistic explanation for it. So it becomes really difficult to make sense of the solutions that we get. I hope the idea of SVM, the diagrammatic representation of SVM, what is hyperplane, support vectors, decision boundary, boundary lines, error margin is clear for one and all. Thank you. Do like, share and subscribe to the Ecotechie. If you have any queries, please feel free to post it in the comment section below. Thank you for watching.